So welcome to the Advanced AMC 8 problem series class. So in this class, we're mainly going to be going over the harder problems from past year AMC 8 contests. And we are going to organize them by topic. So today we are going to be doing number theory. And let's just jump into the problems. And if there's any concepts that you guys need help with, we can pause in the middle. So here's a warm-up problem for you guys to try out. Okay, so we have a few answers. So in order to do this problem, let us see first. The positive integers x and y are the two smallest positive integers for which the product of 360 and x is a square, and the product of 360 and y is a cube. What is the sum of x and y? So here, first we have to try the prime factorize 360. So 360. Can anybody tell me the prime factorization? Okay, so we have 2 cubed times 3 squared times 5. And that looks to be correct. So here we have a prime factorization of 360. And in order for something to be a square, then all of its powers have to be divisible by 2. And in order for something to be a perfect cube, then all of its powers have to be divisible by 3. So we're told that 2 cubed times 3 squared times 5 times x is a square. Well, what does this mean? So for our 2 term here, 2 to the 4th would be the next power of 2 that can give a perfect square. And in order for that to happen, that means x has to have a 2 in it. And 3 squared here is already a perfect square, so we can ignore that. Now 5 here, you need to multiply by another 5 in order for it to get 5 to an even power, which means x here is 2 times 5 equals 10. Okay, so now let's look at y. So the same setup here, 2 cubed times 3 squared times 5 times y has to be a cube. So in order for this to happen, every single one of these powers has to be divisible by 3. And since 2 cubed already works, we can ignore that. 3 squared needs another 3. And 5 to the first power here needs 2 more 5s. And that gives us 3 times 5 squared, which is 75. So if x is 10 and y is 75, then adding them together should get you 85, which is B. So any questions? Okay. So let's move on to the next problem. Let w, x, y, and z be whole numbers. If 2 to the w times 3 to the x times 5 to the y times 7 to the z is equal to 588, then what does 2w plus 3x plus 5y plus 7z equal? Yes, this meeting is being recorded, which means that you'll be able to watch it again on the YouTube channel. And I'll post the link in Google Classroom. So we have one answer already. Two answers. So let me try to start setting up the problem here. Okay, so whenever you're given something that looks like a prime factorization, which is right here, then you should probably be prime factorizing the right side too. So 588, can anybody tell me the prime factorization for this? So we're getting 2 squared times 3 times 7 squared. And that should be correct. Okay, so here we have our prime factorization, and now we just directly compare terms. So notice that here we actually have no 5, which means that it's just 5 to the 0th power. 3 to the first times 5 to the 0 times 7 squared. And now we can directly compare terms, and we see that w is equal to 2, x is equal to 1, y is equal to 0, and z is equal to 2. So they're asking you for this expression, and 2 times w is 4, plus 3x is 3, 5y is 0, plus 7z is 14, and that should give you 21, which is A. So any questions for this problem? If you guys have any questions, please type them in the chat. This class is 1 hour. And it's okay if you can't stay the entire time because you can always watch the recording later. Okay, so let's move on. Okay, so next question here. How many positive factors does 23,232 have? So I'll give you some time to try that. So what you're going to have to do is prime factorize this 5-digit number. On the real AMC 8, you are not allowed to use a calculator, I believe, so you probably shouldn't here. Okay, so let's try this problem. Does anybody happen to have the prime factorization of this number? If not, we can always do it on the board here. Looks like 2 to the 6th times 3 times 11 squared. So do you guys understand how we get the prime factorization here? Okay, good. So to get the number of positive factors, what you do is you always prime factorize the number, and in each of the exponents, there's an invisible 1 here. You always add 1 to each of the exponents, 7, 2, and 3, and you always multiply them together. So in this case, you get 42. So any questions here? So basically, the reason why you add 1 to every exponent to find the number of positive factors is it's really a counting problem. So what this prime factorization means is that there's 6 2's multiplied together. So let's have 6 2's here. And there's also 1 3, and there's 2 11's. So all of these numbers multiplied together gives the number 23,232. And a factor of this number is any number that can evenly divide into it. So really, if you look at it case by case, for example, the 2's here, how many possible combinations of 2 can you have? Well, you can have 0 2's, 1 2, 2 2's, 3 2's, all the way up to 6 2's. So there's 7 possibilities for the number of 2's you choose. And that's really why you add 1 to the exponent. Because you can choose any combination of 2's, but you can also choose no 2's. So 6 plus 1 is 7. And then you have 2 here, and then you have 3 here. So because these are distinct cases, in counting, you have to multiply the numbers together. Yes, it does have to do with 1 being a factor, because if you, for example, in the first case, if you choose 0 2's, then you would be left with 2 to the 0, and 2 to the 0 is just 1. And similarly, if you chose, for example, 0 3's and 0 11's, you would get 1 option here, 1 option here. So you would get 1. And 1 is obviously a positive factor. Okay, so let's move on to the next question. Okay, what is the smallest positive integer that is neither prime nor square and that has no prime factor less than 50? So for those of you having a hard time with this problem, hang on, something happened. Okay, so for those of you having a hard time with this problem, because this problem is a very wordy problem, you don't see many numbers here, and it's just all words. So you really have to try to break it down. So they're asking for a positive integer that is neither prime nor square, and that has no prime factor less than 50. So really what you should be looking at here is this statement. No prime factor less than 50. That means that all the prime factors it does have to be more than 50. So what are some prime numbers more than 50? Well, the smallest prime number more than 50 is 53. And since they're asking for the smallest one, you could be like, well, maybe I could square this number. Because if I just left the number alone, if we just had 53, that obviously wouldn't work. Because they're saying here that it's not prime. So maybe if I square it, it could work. But then you notice that they say it's not a square either. So you start having to look to the next prime number. And the next prime number after 53 is 59. So then with these two numbers, the smallest number you can make is 53 times 59. And it satisfies all the conditions. 53 times 59 is not prime. And it's not a perfect square. And it has no prime factor less than 50. So if we take 53 and 59 here, multiply it out, you get 3127. And that happens to be A. So the way that the class is going to work is each week we're going to have a different topic. So for example, this week and maybe next week, we're going to be just doing all number theory. And then for a few weeks, we'll be doing geometry and then algebra and then combinatorics. Okay, so if there's no questions, let's move on here. Okay, for any positive integer m, the notation m exclamation point, which is pronounced m factorial, denotes the product of the integers 1 through m. What is the largest integer n for which 5 to the nth power is a factor of the sum 98 factorial plus 99 factorial plus 100 factorial? So we have two answers in. Okay, we have more answers in. Okay, so does anybody need more time? Okay, I'll give you guys a little more time. Don't spam me with your answers. Yeah, please don't do that. Thank you. Okay, so let's get started here. So you'll notice that 98 factorial plus 99 factorial plus 100 factorial is a pretty big number. So obviously the way to do this is not multiply it all out and just keep dividing by 5. So the way you do this is first you notice that they're asking for powers of 5 being factors. And normally, if numbers are factors, then a much easier way to approach the problem would be simplifying what they're asking for in terms of something times something else. Because obviously in this form right now, when you have 3 numbers added together, it's kind of hard to factor out 5s. So if you look at the greatest factor that these 3 terms have in common, then you'll notice that it's actually 98 factorial. So let's try to factor out 98 factorial. And obviously the first term is just 1. And 99 factorial is just defined as 98 factorial times 99. So there's just 99 left here. And 100 factorial is 100 times 99 times 98 factorial. So you're just left with 100 times 99. So now you've simplified it into 2 problems. You need to find how many 5s are in this and how many 5s are in this. So to find the number of 5s in 98 factorial, there's actually a formula you can use. I'm not sure if you guys know about this formula, but basically you would take 98 divided by 5, take the floor function of that, plus 98 divided by 5 squared, take the floor function of that, and it technically goes on to 98 divided by 5 cubed floor function, but all those terms simplify to 0. So that doesn't matter. Does anybody want me to explain how the formula works? Okay, so like half of you are saying yes, half of you are saying no, but I'll just go over it really quickly. So basically the way that 98 factorial works is you have 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10, all the way up to 98. So to find out the number of 5s that are in this number, obviously you have a 5 here. You have a 5 here in the 10. And so it looks like every 5 numbers, you actually have one multiple 5. Well, how many sets of 5 numbers are there in the first 98? Well, there's around 98 divided by 5. But 98 divided by 5 is not an integer. And so the reason why is that you've accidentally counted too much. Because when you do 98 divided by 5, the last number that is actually a multiple of 5, which is 95, it counts that, but then you have the numbers 96, 97, 98, and then it just counts that as 3/5 of a set. But there's no actual 5s in there. So that's why you have to take the floor function. And basically what the floor function does is whatever you plug into the floor function, it always outputs the greatest integer that is less than that number. So for example, if I plugged in 6.4, took the floor function, then that would equal 6. If I plugged pi into the floor function, I would get 3, because pi is 3 point something. And you might think that the number of 5s is just 98 divided by 5 floored. But then you're missing the multiples of 25. So for example, there's a 25, and when we hit 25 somewhere in here, then 25 is actually 5 squared. So it actually counts for 2 5s. And so every 25 you have that problem. There's 2 5s instead of 1. So what you need to do again is do the same things except for 25. So take the floor of 98 divided by 25 and add that. And then that will give you the number of 5s. So any questions? Okay, so let's continue with the problem because we technically haven't finished. So we figured out the number of 5s in 98 factorial. But there's another term that we haven't considered yet. So can anybody tell me what actually this number is? So 98 divided by 5 is going to give you 19 point something. And with the floor function, you round that down to 19. 98 divided by 5 squared is 3 point something, so that rounds down to 3, which gives you 22. So we know this number here has 22 5s in it. Now we look at this number, and this number should be easier because that number is just 100 plus 100 times 99, which is just equal to 100 squared. And 100 has 2 5s, which means that 100 squared is just going to have twice that, or 4. And so because you have 4 5s here, and you have 22 5s here, 22 plus 4 is going to be 26. So there's 26 5s in total. Okay, so the person who asked why it's 100 squared, do you get how we came to this step? Okay, so this is basically 100 times 1 plus 100 times 99. So when you factor out 100, that gives 1 plus 99, which is just equal to 100 times 100. Okay, so any more questions? Okay, so let's move on. Oh, the reason why 100 squared has 4 5s is, so 100 can be written as 2 squared times 5 squared, right? That's the prime factorization. So if you square both sides of this, then on the left side you have 10 or 100 squared, and then on the right side you have 2 to the 4th times 5 to the 4th. And so here you'll see that you have 4 5s. Okay, what's your question? Floor. So Floor. And there's another function called ceiling function, which is just, it looks like this. And it's basically the opposite of floor. So it's the number right above that, integer right above that number. The reason we need to add the floor function of 98 divided by 5 squared is 98 divided by 5 squared is not an integer. So with respect to multiples of 25, you have 25, which we count once. And you have 50, which you count another time. And you have 75, which you count a third time. But you don't quite reach 100 because 98 is less than 100. And so that's why you have to use the floor function, because that basically gets rid of the decimal since you only have 3 multiples of 25. And okay, so guys, in the future, if you have any questions that are kind of like off to the side or they don't impact the question as a whole, then you can direct them towards Benjamin. Okay, so next question. The least common multiple of A and B is 12. And the least common multiple of B and C is 15. What is the least common multiple, the least possible value of the least common multiple of A and C? Okay, so it's always good to convert the words they're saying into notation. So they're saying that LCM of A comma B is equal to 12. And LCM of B and C is equal to 15. So 12 is equal to 2 squared times 3. 15 is equal to 3 times 5. And they're asking you for the least possible value of LCM of A and C. Okay, so you'll notice here that both of these have a B in common, which means that B must be a factor of both 12 and 15. So if you look at the prime factorizations, what number is a factor of both? Well, you obviously have 3. So if you let B is equal to 3, then you can get that A is equal to 4 and C is equal to 5, which means the LCM of 4 and 5 is 20. And the great thing about these types of problems is that there's answer choices. And if they're asking you for the least possible value, and the number you get is actually the smallest number in all of the 5 answer choices, then you know you're right. So any questions? Okay, so let's move on. Okay, Mrs. Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All 3 called her on December 31st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? So does anybody need more time? Okay. Okay, I'll give another minute or two. Okay, so I'm going to start going over the problem. So of the 3 grandchildren, one calls her every 3 days. One calls her every 4 days. And one calls her every 5 days. So during the next year, there are 365 days in total. And you might be tempted to say, well, since the question's asking how many days did she not receive a phone call? Well, we know for the first grandchild, then she doesn't receive a phone call 2/3 of those 365 days. And for the other grandchild, 3/4 of the 365 days. And for the other grandchild, 4/5 of the 365 days. And you might be tempted to say, well, let's just add all those numbers together. And if you try to add 2/3 times 365 plus 3/4 times 365 plus 4/5 365, then you'll get a number that's more than 365. And that's because there's a lot of overlap. So for example, on every 12th day, the grandchild who calls every 3 days and the grandchild who calls every 4 days calls at the same time. So this is not a good way to approach the problem. And instead, what you can do is you can use pi, which stands for the principle of inclusion-exclusion. So do you guys want me to go over what pi is? Okay, so most of you are saying no. So I won't go over it, but if you have any questions, you can message Benjamin. So basically, let's take our 365 days, and we're supposed to subtract off the ones where they do call her, since they're asking for the ones where they don't call her. So with the ones where they do call her, is we know that 365 divided by 3 is the number of days that one of the grandchildren call her. And obviously what we need to do is we need to floor this because it's not divisible by 3 and it'll give you a decimal. So then let's subtract 365 divided by 4 minus 365 divided by 5. So this is the number that you might have tried to get as an answer if you didn't know that there were overlaps. So now that you know that there are overlaps, you have to add back the numbers that you missed. So you have to add back 365 divided by 3 times 4 plus 365 divided by 4 times 5 plus 365 divided by 3 times 5. But then you'll notice that on every 60th day, where all 3 children call her, you're overcounting that again, which means you have to go back and subtract 365 divided by 3 times 4 times 5. And so I believe this should be the answer. This whole thing right here. So we already went over the floor function last time, so I'm not going to calculate this, but does anybody have any questions? Okay, so we're going to move on. I honestly don't know what the answer is, but because I am not going to calculate this whole thing during class, but if you guys want, you can try to do it yourselves. Just remember that when you divide, the floor function means that you're taking the greatest integer that is less than that number. Okay, so we're going to go over to the next problem. Don't forget that if you had any questions with this problem, you can go to Benjamin. Okay, next problem. Students guess that Norb's age is 24, 28, 30, 32, 36, 38, 41, 44, 47, and 49. Norb says, at least half of you guessed too low, 2 of you are off by 1, and my age is a prime number. How old is Norb? Okay, so this is a relatively easy problem. A lot of you are getting the answer already. There's no need to spam. Okay. Okay, so let's just go over this. I think most of you are able to get it. Okay, so at least half of you guessed too low. And the good thing here is that the problem actually gave you all the guesses in order from least to greatest, which means the half that guessed too low is just the half to the left, which means I believe there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So halfway should be here. So we already know that all the guesses from 24 to 36 are too low. And so let's look above 36. They also tell you that his age is a prime number. So let's just keep trying primes above 36. And the first prime above 36 is 37. And you'll notice that it says here, 2 of you are off by 1. And the two numbers 36 and 38 are both 1 off from 37. So basically we got it. It's 37. So any questions there? Okay, so let's move on. For how many positive integer values of n are both n over 3 and 3 times n 3-digit whole numbers? Oh, thank you, Lucy. Okay, so let's go over. Um, oh, someone has a question. Okay. I'm just gonna go ahead with the problem. You can go ahead and ask your question. I'll keep looking at the chat. So both n over 3 and 3 times n are three-digit whole numbers. Basically, what we've been doing during this class is we've been going over past year AMC 8 problems, and the topic here is number theory. So if you want to catch up on the stuff you missed, you can. This video will be uploaded on YouTube later, so you can always visit there and rewatch it. Okay, so three-digit whole numbers. The least three-digit whole number is 100. The greatest three-digit whole number is 999. And they tell us that, first of all, n over 3 has to be within this range. So if you try to isolate and multiply both sides by 3, you get, hang on. Yeah, so you get 300 is less than or equal to n is less than or equal to 999 times 3. And if you consider the second case, which is that 3n is a three-digit number, which it means it's in between 100 and 999. So then divide both sides by 3. You get 100 over 3 is less than n is less than 333. So let's say you have this inequality here and this inequality here. So if you combine those two inequalities, this inequality here tells you that n must be greater than or equal to 300. And here, this inequality tells you that n has to be less than or equal to 333. So you're left with this range. And when you're combining these two inequalities, you're always looking for the strictest conditions. So the reason why we ignored this one here and this one here is because there were more strict conditions that were telling us what n could be. So now we have n is in between 300 and 333. So from here, you might be tempted to choose E. But don't do that, because you'll notice here that they tell you that n divided by 3 is, more importantly, a whole number. And in order for that to happen, n has to be a multiple of 3. So not every single n within this range works. Only the multiples of 3 do. And it turns out that there are only 12 multiples of 3, which means the answer is A. So does anybody have any questions? Okay, so the topic for next week's class, okay, so we're almost done. There's like 5 minutes left, but we still haven't covered all of the number theory problems, I think. So next time we'll probably continue doing number theory. And then I think after that should be geometry. So that'll be interesting. Depending on how I'm scheduling the rest of the course, I might be able to give homework. which will just be the problems that we don't have time to go over. Handouts are a little interesting because this is kind of like a problem-based class, and we're not really covering like specific formulas or anything. But if you review past year AMC 8 problems, then you should be fine. Okay, next question here. How many 4-digit positive integers have 4 different digits where the leading digit is not 0? The integer is a multiple of 5, and 5 is the largest digit. So this is, once again, another wordy problem. So you're going to have to try to break the words down into numbers. So I'll give you guys a few minutes for that. So this problem is kind of a number theory problem mixed with a counting and probability problem, but it should still be very doable. Does anybody need more time? Okay, I'll give you guys a few more minutes. Okay, so I'm going to get started here. So this problem gives you several pieces of information. First, they tell you that this number is 4 digits. Then they tell you that the digits are different. They tell you that the leading digit here is not 0. They tell you that the number is a multiple of 5. And finally, they tell you that 5 is the largest digit. So when you're looking at these pieces of information, the first piece that your eyes should really go to is that the integer is a multiple of 5. Because that's kind of the one that will give you the most information. So if you know your divisibility rules, you know that an integer is a multiple of 5 if and only if its ones place digit is either 0 or 5. So we can proceed with casework. So case 1 is when it ends in 5. So if our number ends in 5, we know it's 4 digits. 1, 2, 3, 4. 5 is here. So once we put 5 down, the condition here that 5 is the largest digit is satisfied already. So we just have to make sure that the other digits are no bigger than 5. And because the digits are different, the other digits can't be 5 either. So they have to be 0, 1, 2, 3, or 4. Now they tell you here that the leading digit is not 0. So our first place here has 4 options. It can be 1, 2, 3, or 4. So that gives you 4 options here. So once you've chosen your number there, you can't use it again. Because here it says that there's 4 different digits. So for your second place here, you can now start using 0. Oh, sorry, that wasn't me crossing off D and E. That was me underlining that 5 is the largest digit. So the second place also has 4 possibilities, because even though we crossed off a number that already went into the first place, we added 0 into the mix. So we still have 4 options. So for the next number in the third place, then our options start going down, because we can't use the number we've used here. We can't use the number we've used here. And so then that means that there's only 3 options left. So, and of course this 5 here is fixed. So the total number of options here is 4 times 4 times 3, which is 48. So any questions on this first case? Okay, I'm going to write 48 here in the corner because I'm going to erase this case. Okay, so our second case is going to be the case where it ends in 0. So case 2 ends in 0. So let's once again draw our places here. So 0 here is fixed. And they tell you that 5 is the largest digit, which means that there has to be a 5 definitely in one of the other places. But since all the digits are different, there are no other 5s. So let's say, for example, we put the 5 here, because we know we have to have a 5. Well, then how many other numbers possible are there? Well, we've already used 0 and 5, and there can't be numbers more than 5. So that means it's either 1, 2, 3, or 4. And we can put any of these 4 numbers in the second place position for 4 possible choices. And once we've used that number for the second position, we can no longer use it for the third position. So now for the third position, there's just 3 left. And so 4 times 3 gives you 12 for this subcase. But you could also put the 5 in different positions. So for example, if, for example, you put the 5 here, then for the first place position, since the digits all have to be different, then you have 1, 2, 3, or 4. And you'll notice that actually this case is kind of a similar thing to the last case, as in there's 4 options for this case, 1 through 4. And once you've used that, there's 3 options here. So 4 times 3 is once again 12. And the third case is if 5 goes in this last position here. But that, of course, is the same thing again. So you have another 12. So for this case too, there are actually 3 cases, and each case has 12 possibilities. So 12 times 3 is equal to 36. And remember that our first case, we got 48. So when you add 48 and 36 together, then you should be getting 84, which is D. So any questions for this problem? Okay, so apart from one guy spamming no, doesn't look like there are any other questions. So it looks like we have passed our time for this class. So thank you guys for coming to the first AMC 8 problem series class. Next time we have more number theory problems to go over. So we'll finish with number theory, and any problems in number theory that we don't go over last time, you guys can do by yourselves at home. So thank you for attending, and I'll post the link for this video in Google Classroom once it's uploaded. And yeah, so thank you for coming, and have a great day, everyone.